Hello guys, welcome back to my YouTube channel. So today we're going to be talking about traits in Rust. Traits in Rust define a shared functionality across multiple types in very simple terms. So think of them as a way to specify common behaviors abstractly. We can also use trait bounds to ensure that generic type exhibits these kinds of behaviors. Also, traits outline methods that a type must have. Types share behavior if they implement the same traits. So I'm just going to go ahead and get into my VS Code and write some code to just basically show how we can illustrate and talk about traits. So for this example, I'm going to be using two different examples. So I'm going to be using a news article and a tweet, and they are available in the Rust documentation if you really want to dive into the nitty gritty details of traits. I believe that this video should be sufficient enough, to explain what traits are. So I'm going to be using two different examples, like I mentioned. And one is a news article that's going to represent everything that a news article should be. So it would have like a headline, a content, and an author and all that. While a tweet itself would have the standard tweets on X or Twitter, the standard tweet length, which is 280, and it's also going to have something like if it was retweeted, if it was quoted, and some all other informations, basically just metadata. So let's quickly dive in. So for this, I'm going to create another file. I'm going to call it lib.rs. So in Rust, the way we write traits is using the traits keyword, and I'll call it summary. In this case, I'm going to explain why I'm calling it summary. But basically, I'll do this and I will define a method for it. So it's a function, and I'll call this function is summarize. So what it does is it summarizes, our content, and it's going to take reference to self, and we're going to return a string. So in order for us to get access to this trait outside of this our folder, we can use the public keyword for that. So use pub, and if I hover over this, it says the keyword pub makes any module, function, or data structure accessible from outside of the external, blah blah blah. So you can definitely like go into more details about what the pub is. So let me quickly talk about what the summarize does. Here we are implementing a single method for the summary traits, and the method's name is summarize. Any type that implements this summary traits must provide its own custom behavior for the summarize method. These are things that we need to take note of. And the compiler itself, so the Rust compiler, ensures that any type with the summary traits has the method summarize available to it. Without further ado, I'll go ahead and define our data structure for the news article, and you know do the implementation of using the trait for the news article. First thing I'll do is I'll create a struct. So a struct, and I'll say news article, and inside the news article I'll have, like I mentioned, headline, which is a string. I would have so the location, so a string. The author is also going to be a string, and the content itself is also going to be a string. So in order for us to implement our traits on our type, which is the news article struct, I'm going to use the implement keyword. So impl implementation keyword, and I'm going to call say summary for news article. Okay, and in this place, I'm then going to, like I mentioned before, I'm going to define um, a function summarize specifically for the news article type or the news article struct. So I'm going to say fn I'll say summarize. I'm going to self, and I know I'm returning a string. So, so in that place, I'm going to format macro, and inside it, so here I'm going to define self, self dot headline, call it headline, then self dot author, and self dot location. Self dot. So this is how we can implement the summary traits on the news article type or the news article struct. So there's an error here. You can just go ahead and think about where the error is, but basically I'm supposed to return a string here. So before doing that, I think if I hover over this, yeah, so there's a syntax error expected a type. So I need to I'll just put in string and I'll save. Yeah. So I'll go ahead and do the same thing for the tweets, which which I spoke about in the beginning of this video. So I'll just go ahead and find the tweet struct. So we know that you can define a struct using the struct keyword, and I'll call this tweet. Okay, and we know every tweet has a username, and it's going to be a type of a string. Definitely, we'll have a content, and reply, we'll set it to a boolean. Then retweet is also going to be a bool, right? So now that we have this, we'll quickly go ahead and implement the summary trait on our tweet type. Implement summary for tweets. And okay, so for here, once again, function summarize. I know that is going to take a reference to self on a string, and I just want to format. So here I'll say self.username and self.content. So taking a look at this, we can see that both the news article and the tweet itself, they implement their own summary traits. And this like enables them to kind of have like provide a unique behavior to the summarize method, which we defined here. So yeah, I think that's basically all how you create a trait and um, you know implement it for our structs and all that. So we're going to go over to learn how we can do something called default implementations for traits. Right. So sometimes it is beneficial to provide like a default behavior for methods within a trait. So rather than requiring like implementations for all the method on every type, default implementations allows us to define kind of like a common behavior that can be overwritten or overridden selectively when implementing the trait for a specific type. So I'll just go ahead and define a summary trait with a default implementation. So I would using our the same traits. So here I'm now going to expand this function. So I'm going to add like curly braces, and in that curly braces I'm going to say string. So this string I'm going to say string dot from, and here I'm going to pass a default value, and this default value I'm going to call read more with three dots. With this, the summary trait here, it defines like a single method, which is summarize, and this default method has like an implementation that returns read more. right? So in case we have like a, a trait implementation that did not define a unique method for itself, right? That is when this is going to run. So I'm going to actually run this. So once again, we are going to change things up a little bit. I'm going to be changing some of the functions, or I'll just be commenting them out and be rewriting them in such a way that we can try to get out the functionality that we need. And we're also going to be using a crate, an aggregator trait that is going to enable us to be able to aggregate and pull everything that we've written in the lib file or the lib file into our main.rs file. So tweets for the tweet itself, for the news article traits summary traits implementation, I'm just going to comment this out and re-implement it. So I'll copy that and paste it here. And I'm going to totally remove everything here. Right? So I'm going to remove everything here. So the reason I'm doing this is because I want to show you what would happen when a type that does not have a default implementation of the summary traits, what happens when we try to use that type after we have defined a default way that it is supposed to act. So now for the tweet itself, I'm going to change up some things, just a few things. So I'm going to copy this, comment this out, and paste this here. And in here, I'm just going to say format. So I'll change this to the @ symbol. Okay. I'll just pass only the username. Move this. And in our main function, I'm going to import them. To import them, I'm going to use something called the aggregator crate. So here we can see I just googled the aggregator crate. So I'm going to be opening this one, the first one, and hopefully we should be able to get. So the aggregator crate has like a documentation that you can read just to get more information about it. There's a docs.rs for the aggregator. But for me, I just want to use this to import things in my code. So I'll just copy this and go back to the code. And here in the code, I'll go to the cargo.toml file. And okay, I already imported it from my previous video and that I did that got deleted. Basically, I'll just save it. I just needed to show how that worked. And yeah, so I think that should be it. Now I'm going to do some things in my main.rs file. And what I'm going to do is going to enable me to be able to import the summary as well as the tweets traits to my main file where we all know that that's like the entry point for all Rust application. So if we need the code to run, we have to somehow import those things into the main folder. Okay, so enough of talking. Okay, so here we are going to be importing the summary traits. I'm using the aggregator. I'm going to import our summary traits as well as our tweet itself into the main.rs. So the first thing I will do, I will just say use aggregator. So after that, I'll say curly braces, and in that curly braces, I'll pass in the summary, which is this, and the tweet. Forget. Okay. Save that, and yeah. So in our main function, we are going to define some values for the news article type as well as the tweet type. And we are going to be passing like the headline data, the location, the name of the author, the content, and all that. Yeah, the same thing. We're going to do the same thing for the tweets, and we're going to be passing the username, the content, if the person replied or not, some things like that. So the first thing I'm going to do here, I'm going to define the headline. So I'm not defining the headline, the news article. So I will call it article, and in there, I'm going to say news article. So, okay, and I'm going to say headline. We know that it is a string. So string dot from the news headline is going to be this. Um, okay. Also, I'm going to do same thing for the location, Nigeria. Um, don't forget commas, prevent error. Then the next one is going to be the author. So this one is going to be the author. In this case, I'm going to give it to Shivan. And then the content itself is going to be more from his tweets. So content. Okay. So that will be all for the news article. Then we'll do the same thing too for like tweets. So say let's tweet, call it tweet, and here have a username. Yeah. And the next one is going to be our content. Reply is false. Retweet is also false. All right. So after that, I'm now going to print. So print line, and I would say new article available. So I'll just say article dot. In order to use this, I would say article. Something is wrong somewhere. My code. Okay, so there is an error here. So deleted. Okay, new article. Okay, so I have the code outside. Exactly. So I'll say new article. Not new article, sorry, article dot, we'll call the summarize on it. So we have the summarize function here. You can see how it references the function dot self that we declared in our lib.ros file, right? Which is the function, like the inbuilt function itself. So I'll just go ahead and put that there. And I'll do the same thing for the tweet. So say print line, and in the print line, I'm going to say one new tweet, new tweet, tweet, and I'll say tweet dot summarize once again, right? So when I save this and I run the code, right, we'll take note of what is going to happen here. When we run this code, so I will just increase the terminal. So I'll say cargo run. So as you can see here, I have new article available. So basically, what has happened here is that use a we've been able to use a default read more for the news article, which we did not define a method for, and for the tweets itself, we've been able to get the author's name. So we're just going to go over to the next one, which is traits parameters. So we can use traits to define functions that accept many types. We leverage the summary trait itself in this case that we have implemented for news articles and tweets articles. So doing this, we're going to look at an example, and so we'll create a function which we call notify. So the notify function would call the summarize method on its item parameters. This parameter should be some would be some kind of type that implements the summary traits to achieve what we want to achieve in this case. And here we'll use the implement um, trait syntax. So without wasting much time, I'll just go in and go into our lib file. And here I'm just going to write our function. So I'll call it pub and so pub fn, and I'll call it notify. On here, I would say item. So item is going to take reference to the implementation itself, and yeah, implementation summary. Okay. And in there, I would say print line, breaking news. After that, I'll say item dot. We should get this summarized. We should get access to item dot summarize. And don't forget to put your semicolon. So, so what's happening here is instead of copying the concrete, instead of specifying a concrete type for the item parameter, we use the implement keyword followed by the name of the trait. So this parameter now accepts any type that implements the specified trait, which is this item parameter accepts any type that implements the specified traits. So inside of this our notify function, we can then call any method on the item itself, that comes from the summary trait, just like we did here, item dot summarize. So also we can have two parameters that implements the summary, doing so with the implement trait syntax. So we can do something similar to this for two different parameters. And I'll just quickly give an example of that below here. So I would say I can do something like this. I'll say pub, or I can still use the previous function. So we can just use a comma and would say item 2, item 2. And for this item 2, we still do the same thing. So the implement summary, traits on it. Right. So we can do this for two different parameters and it should still work. So now let's go over to trait bound syntax. So while the implement trait syntax works well for straightforward cases, it's actually a shorter form of a more verbose syntax known as trait bounds. So I would quickly show you you know that example in the code editor. So I'll comment these things so don't call this trait bounds, and then the other one is traits parameters. So this one is trait parameters. Traits parameters. For the trait bounds, we can find another function, another public function called fn, and we would call it still the same name, or just say notify to. And here I would kind of like doing something similar to generics. So I'll say the summary itself, summary, I'll close this and pass our bracket, and I'll say item parameter is taking a reference to a generic type, which is T. Yes, and I'll still say that same print line, whatever. All right, so breaking news, pass this here. So breaking news, item dot summarize. So like I said, the T here, right, is a generic type parameter considered by constrained to the summary trait itself. This syntax would allow us to specify more complex constraints on generic types. So using the implement trait is appropriate if we want a function to allow one or two parameters that have different types, as long as they all implement the same type, as long as both types are implementing the same traits, which in this case is the summary trait. So we can also force two parameters to have the same type. And if we want to do that, we can have like a syntax like this. So I'll add a comment here. I'll say qualitrate bounds for two params of same type. And here we can say same pub function. So I'll just take this, paste it here. I'll call this 3, notify 3. And what would happen here is I'll just use like a comma and I'll say item 2t. And it's as simple as that. So here we are. So the generic type, so in this case, the generic type, which is t, specified as item and item 2 parameters. So they are constrained to the function such that the concrete type of the value passed as an argument for type 1 and type 2 must be the same. So that's something to take note of, that the value for the two of them must be the same. So let's look at multiple trait bounds with the plus syntax. Plus syntax. So we can specify multiple trait bounds with like using the plus syntax. So for example, if we want our notify function to use like a display formatting as well as the summarize traits on an item. So in this case, we want two different like multiple traits, and we can use the plus symbol. So once again, I will say pub fn and I'll call it notify for. And for this, normally we'll take an item, and that item is going to now be a reference to. So here we're going to pass in the implementation of the summary itself. We know that it is a trait plus the display. So the display itself is is a format trait for an empty format. So implementing this trait for any type will automatically implement the toString traits for the type, allowing the usage of the toString method. So this is something coming directly from Rust. You can go further to read how and see how it works. In a situation whereby you find yourself where you want to use multiple traits, you can use this syntax where you pass the item and pass a reference to it and use the implement keyword and use a summary plus the display itself. So yeah, that's one way to go about it. So next we're going to talk about clearer trait bounds with where clauses. So we could use like a where clause to make like a clearer trait bounds. So once again, I'm going to add a comment for this to just make it more clear. So so the reason why we do this is because when dealing with trait bounds, the function signature, the fact is that the function signature can become very cluttered. So this is why Rust provided an alternative syntax using the where clause after the function signature to make the code more readable, right? So if you want your code to be more readable, this is like something that you definitely want to do in your code. So so we're going to say, so instead of what we did here, right? So instead of what we did here, we're going to do something different. So it's a function called the sum function, and looking at it, you can see that it has the T generic, and we have the display plus the clone, right? We have the U generic that has the clone plus the debug itself, right? And after that, we then have we then have the T parameter, which is a reference to the T generic, the U parameter, which is also a reference to the U generic, and this function returns an I32 itself. So instead of doing something like this, right, we can go ahead and rewrite this function using, so I'll say here, I'll say instead of this, we can do this. So I'm very, okay, we can do this. So we'll define our function once again. So I'll say sum function. And here, instead of doing what we just did before, so we'll just pass our generic type. So we'll say T and U and pass our bracket. And inside our bracket, we just pass the parameter and the references. So the references to the generic type. So we'll say dollar sign and symbol, sorry. And here we'll pass another one, which is the U. And there to pass our U. So change this to small letter. And at the end of the day, we'll return an I32. And after doing that, after doing this, right, you see how clean this is. So now we can now use the where clause. So we can say, so we can now use the where clause after the I32, right? We do this after the I32 before the curly braces. So we can say where T, right, is first to display. So display plus clone, and we'll use a comma and go ahead to say U, where U is also clone block and debug. Right, so I can just take this down like this, down like this. So this is how we can make, take a step further to make this code cleaner. So next, we're going to look at how we can return types that implement traits, right? So I'll just add a comment here with this. So returning types that implement traits. So we can use the implement trait syntax in the return position to specify that a function returns a value of some type that the trait implements. And I know that sounds kind of confusing, but the return part that I'm talking about is here where we have the I32s, right? The arrow with the I32. So that's like the return part. So I'll write another function that I will call return summarizable. And in the return part of that function, I'm going to pass the summary trait to that return part. Then I'm going to explain what would happen in that case. So without wasting much time, I'll just say to fn return some return. Let me just say fn return summary, and here, so here I'm supposed to return like something like a string or stuff. I'll just go ahead and return the implement summary, right? And here I can then pass whatever it is I want to pass, right? So I can say tweet, right? So I'll say tweet, and inside here I can pass the username. So the username is going to be a string, and my comma here, and the next one is going to be the content. So the content, and the next is going to be the reply. So the reply is going to be a false. Yeah. I'm going to have the retweet itself. So in this case, it's also going to be false. We wrote a function called return summary. So this is a function that returns a a type that implements the summary traits. Right, I'm even seeing an error here, so I made an error. So so this is supposed to be summary. So it returns the summary traits. Going over this, you can see pub trait summary, right? So it returns it has the return type that implements the summary traits. The type of the return value is the tweet itself, but it is specified in the function signature using the implement summary, which means that the caller would know the type that the return type would implement, which is the summary tweet itself. Sorry, which is the summary traits itself. This use of the implement traits in the return position is very, very useful when we want to hide like the concrete type from the caller and only expose the fact that we are implementing a certain trait. Right? I'm trying to put my words together. So this is very useful for abstraction as well as encapsulation, ensuring that the implementation details are hidden while providing a guarantee about the capabilities, and in this case that is the trait in this case. So that means the capabilities are returned like at the returned value. So we're going to go over to the next one, and this one is going to be we're going to be talking about conditionally implementing methods based on trait bounds. So I'm also going to add a comment for this. And here, so for this, we can use trait bounds with the implement block, that is the impl keyword block, that uses generic type parameters to conditionally implement methods for types that satisfy specific traits. So let's look at an example type. So for instance, we're already importing the display macro. So we'll go ahead and write a new struct. So I'll call this struct a pair. So I'll say struct pair. And this struct takes a generic, which is t. And here we have x, t, and we have y, which is also t. So after doing that, we'll go ahead and implement the display and the partial odd or partial, and which are two traits. And the partial ORD helps us to, I think we use it for comparison. So when you want to compare if something is greater than, less than, equal to, and the display itself is for like, displaying things like it sounds like displaying. So we're going to be using these two traits. We're going to be implementing these two traits on the pair itself. So to do this, I'll say impl, and take note that these two traits are coming from from Rust. So we're going to say t, and t, I'm going to say display. Then remember the plus sign when we want to use multiple traits like I showed earlier here. Where is that? Here, right? So I'm going to still do that same thing. So I'm going to call this partial ORG. So we have partial EQ. So you can see when we want to do like comparison for greater than, less than or equals to, or greater than or equal to. So I'll call partial ORD, which is a trait. So if I hover over this, and you can see that this is pub trait partial ORD, and then traits for types that form a partial order. All right. So you want to do something like the um, less than or equal to, greater than or equal to method of these traits can be used. So, um, so after that, I would close this, and then I would call my pair itself. So it's just similar to what we had done before. It's the same thing, nothing, nothing complex. So I'll pass the t, which is the generic, And if I go up, I can like show you what how this is similar to what we had done before, right? So it's similar to like this implement block here, right? So when we are implementing the summary tweet for the summary traits for the tweet type. So it's just the same thing that we are doing here. And remember that the tweet type is a struct, right? So the only difference in what we did here is that we are now getting these two traits from Rust itself. Like it's they are inbuilt traits in Rust, and we defined our own struct, and we are just saying implement a generic type, which is for the type of T, it should be display plus another trait should be the partial ORD. And we're implementing it on our type, which is the pair type. That also has a generic type. That has the generic T in it too. So it's at the end of the day, it's not that complex if you really think about it. Right. So inside this place, we always have to like define a method, just like we've done every time. So like we did for this part where we defined a method for the tweet itself specifically. So we'll do the same thing in this case. And for the first one, so the first one we'll do would try kind of like do like a kind of comparison. So I'll say fn and I'll say cmp. I'll just say compare display, and once again still the same thing. So reference to self, and yeah, so here I would say if self dot x is greater than or equals to self dot y. So we want to do something, right? So we want to print something. So here I would say print line. So say the larger norm is x, and it is equals to formatter say self dot we have x here. Right. So if I hover over that x, you see that it is a generic type of t, which means it can be anything, right? It can be so it's a generic type of t which we have in our struct. Then I will go ahead and say else I want to print line. We say else we say the larger norm is y. It's just like we're doing the opposite. So I just feel like I would have just copied this and pasted. But here I'll say self dot x, sorry, self dot y. I'm sorry about that. And don't forget to put the semicolons. Yeah. So what we're doing here is that because we've passed in the partial ORD traits, which enables us to do this kind of comparison, which enables us to do some kind of comparison, we're able to use those comparison in this function. So you can see how we've been able to achieve this. So you know the pair that is the struct, the pair t, this which is the struct itself, this type, it always implements a new function. It's something that you have to take note of to create a new instance of the pair itself. I don't know if that makes sense, but basically, the function, which is the CMP display function, we have conditionally implemented a method for it. It is only available with the inner T type. Okay, so let's go over to the next one, and this is we're going to call this I think blanket implementation. Implementation. In Rust, we can conditionally implement a trait for any type that satisfies another trait. These implementations are called blanket implementations, and they are widely used in the standard library, right? So, for example, the standard library implements the toString trait on any type that implements the display trait. I've mentioned this previously. The implementation looks similar to what I'm going to be like the code I'm going to be writing. So it looks similar to something like this. So say impl and t and display. Delete this. So it looks similar to something like this to string for, let me say, for t, right? It looks something similar to this. So this is just like an example. So this is just an example. So because of this blanket implementation, we can afford to call the toString method, which is defined by this stuff that we have here, that is toString, on any type that implements the display trait. So, this enables us to be able to convert, a number to a string, where we have something like let s be equals to three dots, you know, to underscore string and parentheses, so something like, let me just quickly, show the code. So enables us to be able to do something like this. You know, it enables us to be able to do something like this in our code. So yeah, so I'm just quickly going to round off by talking about the compile time safety of traits. So traits and traits bounds allows us to write code that use generic type parameters to reduce duplication while specifying a desired behavior. The Rust compiler checks that all concrete types used with our code provides the correct behavior at compile time. So this approach really improves performance without sacrificing the flexibility of generics. So in conclusion, I would say traits in Rust empowers us to write code that is very concise and expressive, not expensive, and at the same time ensuring compile time safety and performance. Yeah, so one of the greatest advantages of traits is that it enables code reusability. I recently did a poll on Twitter where I, asked people this question. So I will just quickly look for that tweet. So I had this tweet. I made this tweet on Twitter where I just asked people about what do they think about using traits in Rust. What do they think is the biggest benefits of using traits in Rust? And a lot of people, initially people were going for the enhanced type safety, but at the end of the day, um, it all comes down to code reusability. So, guys, that would conclude this video on traits in Rust. If you found this explanation insightful, please like, subscribe, hit the notification bell for more content like this. And I am sorry this video was was rushed because the initial one I made, I forgot to save it. So somehow it got deleted. Thank you guys so much for following me, liking. My last video was, the the amount of love I got from that video, the amount of love I got from that video was really, really encouraging. Thank you guys so much for believing in me, following my videos, and I'll see you in the next one. Bye. Peace.